Hello, I'm Erdem from Movizon. In this video we will analyze the circuit by mesh analysis. Alright, first step is to choose a ground node, and I'm choosing this node to be the ground. Remember, this step will never affect your analysis. Second step is to assign mesh currents. Let this mesh to be the mesh X, this is mesh Y, this is mesh Z, and a current flowing around mesh X is IX, this is IY, this is IZ. Observe that these two meshes, mesh X and Y, are related with current source I1, and mesh Y and mesh Z are related with current source I2. So we can construct a super mesh between meshes X and Y, and we can construct a super mesh between mesh Y and mesh Z, right? So I'm now drawing you the Supermesh circuit. Alright, I'm omitting current source I1 and current source I2. This is R4, this is R5, this is nothing, this is R2, and connect. Now let me draw the borders. Current flowing around this mesh is IX. This is IY. Here we have R3. And in this part of the circuit, flowing current is IZ. So when we write down KVL in this part, we will take the current as IX. When we write down KVL in this part, our current will be IY, and in this part our current will be IZ. So let's write KVL for Supermesh. I'm starting from this point. First component is R3, and current IY is affecting on it. So voltage difference across it could be found by multiplying IY times R3. Next component is resistor R2, and voltage across it is IY times R2. Now our component is R1, and this time IX is affecting on it. So we will write IX times R1 to find voltage difference across it. Next component is resistor R4, and IZ is affecting on it. So IZ times R4 is voltage difference across resistor R4, and R5 is affected by only IZ times R5, and we have reached the start point, so we will write 0 by KVL. In this equation we have 1, 2, 3 unknowns. We must have 2 more equations. How we will write that equations? I'm setting this out of screen, and I will try to write down. Actually, we can relate IX and IY on this part of circuit, current source I1. Notice that IX is in the same direction with I1, and if we subtract IY from IX, we can get the value of I1, right? So Ix minus Iy is actually equal to I1. We now have two equations. We need one more. We can relate Iy and Iz here. And Iy and I2 is in the same direction. If we subtract Iz from Iy, we can get the value of I2. So, Iy minus Iz is actually equal to I2. These two equations are called constrained equations. And before labeling these two currents, we could have written for Iy we could have written Ix minus I1, and for this one we could have written down Ix minus I1 minus I2, right? With this way we are avoiding two unknown mesh currents. We are avoiding writing two unknown mesh currents. So we have only one unknown when we write in this way the mesh currents. So here we would have Ix minus I1 for Iy, right? And for Iz we would have Ix minus I1 minus I2. So we would have only single equation, and that could be solved with one unknown. So that's your choice. If you label three unknowns and you write constraint equations, or if you don't write down these two unknown currents, you have one single long KVL equation. That's your choice. Thanks for watching.